Hi students, pleasant good morning to all. I hope that you all enjoyed your holidays. So students, the last class what we studied, do you remember? What are the questions we have learned or what are the topics we have learned? Yes, we have studied about Rutherford model of atom, Neil Bohr's model of atom. Two important questions. I hope that in the holiday you might learn these two questions. Today we are going to learn the characteristics of fundamental particles. The characteristic of fundamental particles. I hope that already I have said this to you, isn't it? We have studied this under subatomic particles. So, what are the subatomic particles or what are the fundamental particles that present in an atom? Yeah, proton, electron and neutron. Good. Proton carries what charge? Positive. Electron, negative. And neutron does not carry any charge, isn't it? It's neutral. Who discovered the presence of or who discovered the presence of neutrons in an atom? Do you remember the last class I mentioned? It is by James Chadwick, isn't it? Alpha rays were bombarded with beryllium ions. So, a mass equal to that of protons were emitted and it was captured by a detector. It does not show any charge. From that, he concluded that inside the nucleus, there is a proton and also a chargeless particle. What is that? Neutrons, isn't it? So, proton, electron, neutron. The charge. Also, you know, isn't it? Now, mass. It is in grams, okay? It is expressed in grams. So, nearly 1 proton is equal to 9.1 into 10 raised to minus 28 gram. Electron 1.6 into 10 raised to minus 24. Neutron 1.6 into 10 raised to minus 24. Isn't it? I said that the mass of what? Electron is negligible. The mass of electron is negligible. The mass of electron is negligible. Okay. The next one, two structural parts of atom. Two structural parts of atoms. So atom contains mainly two parts. They are orbit and nucleus. What is orbit? Orbit is defined as what? They are the stationary circular path in which the electrons revolve around the nucleus, isn't it? Already we studied orbit. What is orbit? Isn't it? For example, if it is a nucleus, these are the circular paths in which the electron revolves. So this is called as nucleus and the circular stationary paths are called as what? Orbit. So atom has two parts. What are they? Nucleus and orbit. So orbit means what? Important 2 mark question. They are the stationary circular path in which electrons revolves around the nucleus. And nucleus, inside the nucleus what are the things present? It contains proton and neutron. Good. Nucleus contains two components. That is what? Proton and neutron. This proton and this neutron together called as nucleons. Together called as what? Nucleons. This proton and neutron together called as what, ma? Nucleons. So students, two important parts of the atoms are, what are they? Orbit and nucleus. The component present inside the nucleus is collectively called as nucleons. Okay. Other than these subatomic particles, the main subatomic particles or these main fundamental particles, okay, scientists also discovered some other particles which does not have much values. Okay, what are they? Means mesons, neutrino, positrons, quarks. Other than that, okay, quarks, gluons, etc. Okay, these are the some of the particles. Other than these major particles, some others or some scientists, they found that other than these three major subatomic particles, atom also has, the empty part of the atom also has mesons, neutrino, positrons, quarks, gluons, etc. Okay, the next one is atomic number and mass number. It's an important one. Okay, atomic number and mass number. Atomic number and mass number. Do you heard this word before? Atomic number and mass number. First we are going to learn about atomic number. First we are going to learn about what, students? Atomic number, isn't it? So what is atomic number? Means it is a total number of protons present in the nucleus, isn't it? Which one determine the element? Means the elements are identified by the presence of the number of protons or number of electrons. Number of protons Number of protons or number of electrons only determine the name of the element. So the name of the element is determined by the presence of protons. Okay, and also I said that atoms are electrically neutral. Atoms are electrically neutral. See, because the total number of proton is always equal to of total number of electrons that present outside the nucleus. Inside the nucleus, if it contains 5 positive 5 proton, outside the orbit contains what? 5 electrons. So total charge of the atom is what? 0. Atom is electrically neutral because they contains equal number of charges, equal number of positive and negative. Hence atom is said to be electrically neutral. Hence atom is said to be what? Electrically neutral due to the presence of number of protons and number of electrons. So from this we understood that always proton is equal to what? Electron. Okay. So atomic number means either it gives the values of proton or it gives the values of electron. If the atomic number is 5, okay, if the atomic, for example, if the atomic number is 8, then it denotes the atom contains what? Proton 8 as well as what? Electron 8. So if the atomic number is 8 means it denotes the total number of proton in an atom is 8, electron in an atom is what? 8. Okay, and this atomic number was denoted by the letter Z. Z means Zahl. Z means what? Zahl. So in the German, okay, this is a German words. So atomic number was denoted by a word Z. Atomic number was denoted by a word Z. Okay, the symbol used to denote atomic number is Z. Okay, that is the atomic number is either the number of protons present in the atom or it denotes the total number of electrons in an atom. So what is atomic number? Atomic number, the word is denoted by a letter Z, and atomic number is defined as the number of protons or number of electrons that present in the nucleus, of an atom. I hope that you all understood what is atomic number. Now we are going to learn about what? Mass number. It was denoted by the letter A, Mesenzahl. It is also used in the word German word Mesenzahl. Okay. So mass number was denoted by the letter A. Okay. Here the mass number already we studied. Which one will give mass to an atom? Atom totally depends upon the nucleus. Totally depend upon nucleus for an atom. It is totally depend upon what? It is totally depend upon what? Nucleus of mass number denoted by the letter A. And I said that atom totally depend upon nucleus for the mass, isn't it? Which one gives mass to an atom? Nucleus. So nucleus contains totally what? What are the components present in a nucleus? Nucleons, isn't it? Number of protons and number of neutrons together called as which number? Mass number. For example, if A is equal to 20, that mass number 20 means the letter 20 denotes, the number 20 denotes number of proton plus number of neutrons together called mass number. So atomic number means either the number of proton or electron. Here proton plus neutron is mass number. It was denoted by the letter Z and it was denoted by the letter A. It was denoted by the letter A. Have you understood, students, what is called as atomic number and mass number? Okay, atomic number means number of protons or number of electrons. Here proton plus neutron together only contributes which number? Mass number. Okay. Students, see we can how to symbolize this, how to write the mass number and atomic number. See, for example, X, you take it as symbol. The symbol of the element should be written at the center. Here you should write the symbol of the element. The mass number at the top and atomic number at the top and mass number at the bottom. You hear like this, you should write. Okay, A and Z. See, X is the symbol. X is what? Symbol. Like this, you should represent the atomic number and mass number. A stands for which number? Mass number. Z stands for atomic number. This is the symbol. For example, symbol, isn't it? Magnesium. We wrote the symbol of Mg means what? Magnesium. This is the symbol. Symbol of magnesium has been written and the mass number of this is A and this is Z. Okay. So mass number is 24. Atomic number is 12. From this, how you can find out neutron? Isn't it? Here mass number, that is here. From this, how you can find out the neutron? It was given by the formula. See here. neutron can be founded by the formula A minus Z. What's the formula? A minus Z. Neutron can be found by using the formula A minus Z. Students, at the bottom, mass number, at the down, atomic number, neutron value, how we can find out, students? By the formula A minus Z. What's the formula? A minus Z. See here, A value are 24. Okay, Z value are 12. The remaining, what's the number you got? 12. It is the total number of neutrons present in the nucleus. Okay, this is a formula to identify the neutron A minus Z. Okay, shall we see one problem? Here mass number is given 39, number of neutron 20. We should find the element. Okay, I already said that the number of electrons or the number of protons only determine what? The element, isn't it? So how can we find out? Here you can take A minus. Okay, for example, neutron, how we can do? A minus Z. Here what we should find out? Z value, isn't it? Z value is not given, so we can take what? A minus, this one, number of neutrons. Okay, A minus Z. From this formula we have taken that Z is equal to A minus, that is mass number minus number of neutron. Mass number, what's the value given here? 39. 39 minus 20, 19. So the neutron present inside, this is the value. Okay, Z value, atomic number, the total number of proton or the total number of electron that are present in an atom is 19. So 19 means which element it determines? Means potassium. K, the symbol is K, potassium. Okay, so the symbol is what? Potassium. So how you will symbolize this? How will you symbolize? Symbol for potassium is K. What is the mass number given here? 39. What is the atomic number we find out? 19. Okay, this is A value. This is Z value. What is the neutron value? Already given here, 20. Okay. So in book, the page number 128. Okay, in the book, page number 128, test yourself, like that it is given. Some activities also given there. So there are nearly 4 problems were given. Calculate the number of neutrons in the following atoms. Calculate the number of neutrons in the following atoms. Students, you take a booklet and do these questions on that note. Okay, already I said to write some questions on that booklet. Along with that, you have to write this question also. You just practice it at home. How to find out the mass number, how to find out atomic number, how to find out neutrons. Okay. Okay. So the next we are going to learn is electronic configuration. Students, did you understood? Okay. So mass number, atomic number we are learning. How to represent that? At the center we should write the symbol. Mass number at the top, atomic number at the down. Okay. And neutrons are found by the formula A minus Z. So number of protons or electrons determine what? The number of what? Determines the element name. So here total number of protons or electron found to be 19. So 19 means what's the element name? Potassium. What's the element name? Potassium. Okay. Have you understood? The next one, electronic configurations. What is electronic configuration? The arrangement of electrons in each orbit, or you can say the distribution of electrons in each orbit. Distribution of electrons in each orbit is called as what? Electronic configuration. Distribution of electrons in each orbit. How the electrons are arranged in each orbit is called as what? Electronic configuration. According to Niels Bohr, we studied one electronic configuration, isn't it? Like a solar system. Do you remember? Found it has shells, and shells are named as what? K, L, M, N. Okay. According to that, today we are going to see the electronic configuration. Next class we will learn how to write the electronic configuration for higher elements. Okay. For few elements, for smaller elements it is applicable. I already informed, isn't it? On last class I said the Niels Bohr's model demerites. It is not applicable with the more number of electrons, isn't it? Only for a small atom it is applicable. Today we are going to learn how to write the electronic configuration based on that. Okay. Next class we will study how to write the electronic configuration for the higher elements. Have you understood? So shall we see? So already in Niels Bohr's model we studied the accommodation of electron in each orbit is given by the formula 2n square. Okay, n is the energy level. Okay, the orbit can be also called as what? Orbit can be also called as shell or energy level. Energy level. Okay, n denotes what number? Quantum number. Energy levels. Okay, quantum. Quantum means what? Energy. Quantum number. Okay, shell energy level. N stands for quantum numbers. That is, each orbit has its own fixed energy level. Each orbit has its own fixed energy levels and it has the capacity to hold the electrons. Okay, now how many minimum or maximum? How many electrons each orbit can be hold? It is given by the formula 2n square. Okay, and also we studied that what are the shells? K, L, M, N. According to this, do you remember? First energy level n is equal to 1, then 2n square. According to this formula, K contains 2, then what? N is equal to 2, 2n square formula, we will get to what? 8. Like this, we found K is equal to 2, L is equal to 8, M is equal to 18, and N is equal to 32. So K can hold 2 electrons, L can hold 8 electrons, M can hold 18 electrons, N can hold 32 electrons. Based on this, we are going to write the electronic configuration for smaller atoms. Okay, we are going to write the electronic configuration for smaller atoms. Okay, in the next class, we will study how to write the electronic configuration for the higher elements. Okay, so for example, we are going to see carbon. First, the smaller atom carbon. The total number of electrons or protons here is 6. Okay, how you will write? First, K shell. K shell can accommodate only how many electrons? 2. So, 2. First we write 2. Remaining how much is there? 4. L shell. L shell can hold how many electrons? 8. But only available is what? 4. So, the electronic configuration is 2, 4. 2, 4. So, this is nucleus. First orbit contain K is equal to 2, L is equal to 4. The outer shell contains what? 4. So 2, 4. Okay students, the carbon total number of electron is 6. So first orbit can hold only 2 electrons, remaining 4. It jump to the next energy level. It has the capacity to hold 8 electrons. Only how much is available? 4 is available. So the remaining 4 occupies here. Okay. Always the electrons because arranged. The maximum number of electrons that accommodate shell is given by the formula what? According to 2n square formula only we are writing. Okay. Shells are filled in step by manner. Okay. First after filling the K shell only the electrons jumps to the L. After L it jumps to the M, but before filling M electrons it can jump to the N electrons. Okay, but first it will be filled in K. So stepwise manner, increasing order of energy level in the increasing order, isn't it? When we move away from the nucleus to the outer orbit, the energy level goes on increasing, and when we move near to the nucleus, the energy level decreases. Already we studied in Niels Bohr's model. So always the electrons fills in the orbit according to the increasing order of energy level, stepwise manner. Okay, the outermost shell. This is the outermost. Here L is the outermost shell. Here L is the outermost because only it has how many electrons? 6. So 2, 4. The L is the outer orbit. L is what? The outer orbit. Okay, have you understood students? Next we can write it for the next element. One more example we can see. For example, sodium. Common example, sodium 11. The total number of electrons or protons. The next one is sodium. Okay, sodium has total number of proton or electron is 11. So now you say K. K can hold how many electrons, students? 2, isn't it? L remaining 9, isn't it? Remaining how much is there? 9. 2 we placed in K. Next, out of 9 can we place in L shell? No, because it has the maximum capacity to hold how many electrons? 8. So we can keep only how many electrons in the L shell? 8. So after filling K, the electrons jumps to the next shell L. After filling L, remaining also we have how much? 1. The KL, next one, yeah, 1, isn't it? So nucleus, first orbit, K is equal to 2. Next, L is equal to 8. last one m is equal to 1. So this is the last orbit of, okay. So sodium atom has 3 orbits. What are they? K, L, M. Okay, what are the 3 orbits? K, L, M. And this is called as outermost orbit. This is the outermost orbit, okay. And the number of electrons that present in the outermost orbit is called as valence electron. What electron? Valence electron. So here valence electron, the outermost or the number of electrons. What is valence electron? The number of electrons present in outermost orbit. Outermost orbit is called as valence electrons, okay. So here see, for example, carbon has 2 shells, K, L. L is the outer orbit, so the valency is 4. The number of electrons present in the outer orbit is called its valency, or the number of valence electron. You can call this the number of electrons that present in the outer shell as either valence electrons or valency, okay. So the outermost orbit here, what is the outermost orbit? M. So the number of electrons in M is 1. Okay, so the valency of sodium is 1. Valency of sodium is 1. And the number of valence electron is out of. Okay, what is valence electron? What is the importance of this valence electron? Means they only take part in chemical reaction. These valence electrons only take part in chemical reactions. They only take part in chemical reactions. So what is valency? It is the that is the number of electrons that takes place in the chemical reaction is called as valence electrons or valency. Okay. Okay, for majority the elements which have valence electron 1, 2, 3 are metals. Okay, see for example valency 1, 2, 3 means they are metals. The remaining is what? Non-metals. The remaining what? From that 4 to 7 is non-metals. Do you understood this, students? We are seeing about valence electrons. The outermost orbit is called as valence orbit. Okay. The number of electrons that present in the outermost orbit is called as valence electron or valency. For example, here the outermost orbit contain 4. So valency is 4. Here outermost orbit contain 1. So valency is 1. What is the valency? Take part in chemical reactions. So number of electrons that present in outermost orbit is called as valency or valence electrons. These valence electrons take place important role in chemical reactions. If outermost orbit contain the total number of electrons 1, 2, 3 means it belongs to metals. Usually the metals in metallic atoms, they contains outermost orbit 1, 2 because they lose electrons. Non-metal they gain electrons. So the non-metals usually have outermost shell, the electrons 4 to 7. Either they have 4, some atoms 5 or 7. Non-metals usually have the outermost orbit 1, 2, 3. Okay, 1, 2, 3. Okay, students, did you understood what is valence electron? These valence electrons only determine the chemical reactions. Okay, because they are only the chemical properties of an atom. We are studying physical properties and chemical properties, isn't it? The chemical properties of an atom totally depend upon the valence electrons because they only take part in chemical reactions. Okay, the combining capacity, everything that takes place only in the outer orbit. Okay, so the number of electrons in this orbit only called as valence electrons or its valency. If the outermost shell contains valence electron 1, 2, 3 means it belongs to metals. 4 to 7 belongs to non-metals. We know metals always what? Loss electron. They always gain electron. Okay. If a valency 4, outer shell 4 means what is that? See here outer shell has 4. So carbon. The valence of carbon is 4. It's a metal or non-metal? It is a non-metal. See sodium has the valency 1. So it is what? Metal. So always the metal will lose the electrons to which one? Non-metals. For example, sodium, chlorine, outermost shell contains 7. Chlorine contains 7. Okay. Sodium contain 1. So sodium give 1 electron to chlorine and they form what? Sodium chloride. Okay, so they undergoing chemical reaction. This valence electrons only undergoing chemical reaction. From sodium 1 electron jumps towards what? Chlorine to form a compound called as sodium chloride. So they take only part in chemical reaction. So the chemical properties of an atom totally depends upon the what? Totally depends upon the valence electron. So the next class, students, we will study detailing about how to write the electronic configuration for higher elements. I hope this one you understood. Okay, so many examples are given in the book. You just go through that, students. And also you should know to draw the atomic structure of an atom. You should also know to draw the atomic structure if the mass number and atomic number is given. For example, you can take carbon. Okay, you can take carbon 12 6. Here, what is the atomic number? I'm sorry, mass number. What's the mass number here? Did you understood what is the mass number? Mass number means total number of proton. Mass number is 12. Mass number is 12. Atomic number is 6. Number of neutron 12 minus 6. 6, isn't it? How to draw the structure? You have to draw the structure for this. So first you have to draw what? A small nucleus. Okay. So inside the nucleus, what are the things present? How many neutron? 6. Electron 6, isn't it? So I'm sorry, proton 6, neutron 6. Okay. So you have to draw 6 proton and 6 neutron. So little large we can draw 6 proton and 6 neutron inside the nucleus. So outside first orbit, electronic configuration, write for 12. Write for 6. K is equal to 2. L is equal to 4. So first orbit 2. Put 2 dots. Next one 4. So this is the atomic structure. Like this you have to draw. Okay. So this is also very important question. Draw the atomic structure for carbon. Draw the atomic structure for oxygen. Like this, if they have given means they will give the mass number and atomic number. You should find the remaining and should write the electronic configuration. Then you have to draw the atomic structure. In the book, page number 131. Okay, many examples are given. Okay. So that and all you have to draw and you have to learn. Students, see Roman number 7. Here a question is there. Do this as a homework. Question number 4 is homework. Third one, draw the structure of oxygen and sulfur atom. It is on page number, see here. This one, atom of phosphorus and atom of sulfur. Draw this, study its atomic number, mass number, because they did not give there, isn't it? At the book it is not given, so you have to learn the phosphorus atomic number, mass number, sulfur atomic number, and you have to draw this diagram. It's a very important question. I hope that you all learned this question. Okay, thank you students. Next class we will study the electronic configuration for higher elements. Thank you.